Welcome. NINO has just issued its global climate update for April of 2023, and this video is a summary of that report. Let's summarize the main points we're going to cover today. We are in an El Nino watch, which means an El Nino is imminent. Ocean temperatures were the highest on record. April was the fourth warmest April on record. Antarctic sea ice was the third smallest extent ever recorded. And carbon dioxide reached a new record high level. So how are these temperatures distributed around the globe? North America had its 15th warmest April on record. South America its 9th. Europe its 3rd. Africa its 4th. Asia was about normal, maybe a little bit above, and the South Pacific was about 11th. Let's look at that numerically. Globally, the overall anomaly was 1 degree centigrade, which is the fourth ranked highest ever recorded. The land was 1.31 degrees centigrade above the normal, which is the 11th. The oceans overall were 0.86 degrees centigrade. Note they are warming less rapidly than the land, and that was ranked number 1. The northern hemisphere was 1.08 degrees centigrade above the long-term average, which ranks it as 9th. The southern hemisphere was 0.93, which ranked it as 1st. And that's again because the southern hemisphere has more ocean than the northern hemisphere. Here we have a plot of the monthly temperatures for April going back to 1850. And you can see that there's 3 phases here of temperature. From 1850 to about 1910, the temperatures were relatively constant. In fact, the overall trend was slightly down, although I think that's within the uncertainty of the measurements. In the middle 60 years of this, the trend was a little more, about 0.07 degrees centigrade per decade. But the last 60 years, the trend has been 0.18 degrees centigrade per decade, which is the trend that we're dealing with now and is likely to go up. That would make it the hottest decade in 173 years, because we'd have all 10 of our hottest years in that decade. However, that's not necessarily the case, because 1850 marks the time when the Little Ice Age temperatures returned to normal. So for the previous 500 years, we were in the Little Ice Age, and so I doubt there was a decade in that Ice Age that would have equaled what we have currently. That would say it's the hottest decade in 700 years. Now, scientists are beginning to show that current temperatures are probably greater than not only the medieval warm period and the Roman warm period, but are rivaling that of the Holocene climatic optimum from 7,000 years ago. So it might be the hottest decade in the last 7,000 years. And once it passes that threshold, it will be the hottest decade since the last interglacial occurred 130,000 years ago. So these are not just normal changes that people like to brush what's happening off now. This is a fairly major shift in our climate, and we should remember that. Are we warming or are we cooling is the age-old question. If you have a particular climate, like shown in this plot here, where 0 is your average temperature, you'll get some days that are colder than average and some days that are warmer than average. But what happens if the temperature starts to increase, the average temperature starts to increase? The curves all shift to the higher temperature, which means you'll get more hot weather and much more extreme hot weather and less extreme cold weather. So is that what we're experiencing at the moment? This is a plot of the temperature as a function of location on the globe, and you can see it's broken into percentiles here, where record coldest is dark blue, and we have no record coldest here. We have a few pixels that are much cooler than average. That's the slightly darker shade of blue. But we have quite a large number of pixels that are record warmest, and most of the map is much warmer than average. So that shows a shift in our overall climate to higher temperatures. Well, if temperatures are rising, ice is going to disappear, and that's what we are seeing at the moment. If you look at the northern hemisphere snow cover, you can see that generally there's been a downward trend over the last 60 years or so. Another trend to watch is sea ice. This is the northern hemisphere sea ice, and you can see over the long term it has been dropping quite rapidly at about 0.36 million square kilometers per decade. We now can compare that with the southern hemisphere, which tells a slightly different story. This is the southern hemisphere sea ice, and you can see there's a slight upward trend. Again, I would argue this is probably within the uncertainty of the measurements themselves. So basically it's been flat. Now let's take a look at adding those two together and get the global picture for sea ice, and you can see that it's actually dominated by the northern hemisphere here. The trend is basically downwards and a loss of about 0.34 million square kilometers per decade. As I mentioned before, we are in an El Nino watch. That means the probability of an El Nino is increasing as time goes by, and this is a plot of that probability. You can see for the next couple of months we'll probably remain in ENSO neutral conditions, but from then on we're going to be likely in an El Nino and an ever strengthening El Nino, with very little chance of a La Nina and a small chance of remaining in ENSO neutral conditions. So this is worth watching, as this affects so much of our global temperatures and weather. Concerning here is that carbon dioxide is on the rise, and it seems to have jumped quite remarkably a large amount in the last month. You can see the last point on here is very much higher. Compared with last year at the same time, we are 3.05 parts per million higher than before. And next month is actually usually the peak of the carbon dioxide before the northern summer gets underway and the plants start absorbing a lot of carbon dioxide from the air. Another thing to be keeping an eye on is the total solar irradiance. I haven't used this before, but it's beginning to become very relevant. This is a plot of the amount of energy reaching the Earth per square meter as a function of time. And you can see it's around about 1362 watts per meter squared. Now, of course, a lot of that is reflected away in clouds and things of that sort, but this is at the top of the atmosphere. This is the amount of energy coming from the sun. And if you draw a line across here, you can see that solar cycle 25 has already exceeded the total solar irradiance from the maximum of solar cycle 24. And we aren't at the maximum of solar cycle 25 yet. We're very close to the peak of solar cycle 23. I'm not so concerned about what happened in solar cycle 21 and 22, because if you look down below, that blue curve shows that the uncertainty on the measurements back then was quite large, so I don't trust those so much. So what can we conclude from all of this? First of all, we're in for a long, hot summer, unless of course some big volcanoes erupt. El Nino is coming, carbon dioxide is still rising fast, and total solar irradiance is getting higher. All of those will contribute to increasing our temperatures. Earth is still warming too fast. 2023 is likely to be in the top 3 hottest years on record, which means that in the period from 2014 to 2023, that decade is likely to be the decade with the 10 hottest years ever recorded, and the hottest decade for up to 130,000 years, which is amazing. Thank you for listening, and until next time, stay safe and goodbye.